Okay, section 2.4, exact equations. So differential equation expression can be written as something like, so there is a term with the dx, there is a term with the dy, and we're gonna call anything with the dx with m, anything with the dy, we wanna call n, okay? And it's a homogeneous equation, meaning equals to 0. And then it is an exact equation if the left side is an exact differential of the right-hand side. I don't know what happened to the rest of the sentences. And I show you. And then to identify it is exact or not, we need to do this. So for this section, we're going to follow these 4 steps. First, we need to check for m and n, and to this see whether the differential equation is exact or not. And then we're going to use x. I'm going to show you both way, do x or do y, partial derivative of x of f or partial derivative of y, and then do this. I mean, by reading this, I mean, you probably don't know what I'm talking about. Okay, so let's go through step by step with the example. Here's the differential equation, step 1. So here is the x portion, 2xy. We're going to let that equal to m. We're going to let n equals x squared minus 1. So find m and n. And then m for my y. So we need to take the derivative of this m respect to y. Then equals to 2x, right? X is the constant. And then n for x. And that is 2x. So now, therefore, my equals to nx. It is exact equation. Step number 2, we need to let partial derivative of this equation x m. And we set m up there, so 2xy. Now we need to find f using this guy. That means we need to take the integral of 2xy respect to x. That equals 2y is the constant, and 2y and 1 over 2x squared plus c. That c is for any constant including y terms, because it was the partial derivative of x, right? If we had a plus y term or y squared plus something in terms of y or other constant, we took that as all 0, right? So we need to write it in g of y here. So basically, this is the solution, but we need to find g of y. This is the solution. I'm going to repeat that again, but we need to find the g of y. So to do that, we want to take that in the from step number 2, take that one, take the derivative of that equation respect to y. We have yx squared, that is just x squared, g prime of y. So in the first term, this x squared is the constant because we take the partial derivative of respect to y. Now compare this, and we have n equals x squared minus 1. That means g prime of y equals to -1. G of y equals negative y. Now, what is the answer we said here? So yx squared, we said yx squared plus g of y, and then you plug it in this g of y here. So y x squared minus y equals to c. That's the answer. In this method, we said either we use this guy or this guy. So for example, if we take, instead of doing this, we can do, I'm not trying to confuse you, okay? So we'll stick to this method this way, but there is a way to use rho f and rho y equals to n. N is what? X squared minus 1. F x comma y integral x squared minus 1, this time with the dy. I'm going to just go quickly to show you. And then that equals x squared y minus y. And then this time we're going to call it plus, I don't know what we did was that, h of x. And then take the derivative of this guy in terms of x, then 2x negative y equals to 0 plus h prime of x. And then we need to compare this with m. 2x, I forgot to put y there. M, and in the m, we have 2xy. So in this case, h prime of x equals to 0. So this is our answer. So x squared y minus y equals to c, which is the same one, right? So you can use n or m, right? It's so confusing, okay? So for our quiz, I'm gonna say, show this equation exact, and so you need to say, you need to show exact step number 1, and then solve. So you just need to go through m, the technique that we did, okay? So let's stick to that. Okay. And for problem 2.4.2, solve this. We take the m, this is n, okay? And they are not the same, so this is not exact, okay? So let's work on this. So we have m equals e to the 2y minus y cosine xy. And we have n equals 2x e to the 2y minus, so m, for m is respect to y. So remember, it's a my, right? For the m, for the y, my. So for the y. So then e to the 2y is 2 times e to the 2y, because we need to take the derivative of 2y, minus, because we have a 2y's. Okay? So the first derivative and second one plus first, second derivative. Cosine x, derivative of cosine is the sine xy, and then take the derivative of xy, that is x. For nx, we have only one x, so 2 e to the 2y. Now we have x and cosine xy. There are two x's. First derivative, second one, plus first, second derivative, sine xy, this time y, derivative of 2y, they're all constant, it's going to be 0. So when you compare, they are the same, so it is exact. And we have n 2x e to the 2y minus x cosine xy plus 2y. So take the integral of this to get f x comma y. So with respect to y, therefore I can take 2x out, e to the 2y dy, minus, can take x out, cosine xy dy, plus 2 out, y dy. First term is 2x times e to the 2y, 1 over whatever the value on the top, and then x times integral of cosine, it's gonna be sine, and then 1 over x plus 2 times 1 over 2 y squared plus h of x. That's the answer. Now we need to find h of x. So h of x, so we need to take this in terms of x. We can cancel 2 and 2 first. And this is constant term. I don't see any x there. So we can just put e to the 2y. Now we can cancel this y. So sine is going to be cosine times y. And then in the last one, the whole thing is the constant. There's no x terms, plus h prime of x. And what was our m? M is this guy. So we had m as e to the 2y minus y cosine xy. Okay? And we compare. Now we know h prime of x equals to 0. Okay? So the answer is set right here, the red one. So now our answer is going to be x e to the 2y minus sine xy plus y squared equals to c.